This video is going over our first lesson of Mock 7, which is our radical expressions. We're getting into radicals in this mock, and our rational or fraction exponents and how they can represent each other. So here we just have to make sure that you understand the vocabulary. So for example, we already know the radical because this here is like our radical symbol. We already know about our exponent here. So like in this case, we have our A. However, just new terms, we have our index. So the index is going to refer to is we could have a value here that represents a different for the value of the radical. So here we have our index, and then the value inside that's being raised to the exponent, we're going to refer to as the radicand. So we have the radicand, and then we have the index. Now, keep in mind what we're going to be focusing on is right here, this concept. So if you notice, if I want to rewrite my radical here as an exponential form, we're going to write it as a fraction. So the exponent is always going to be the numerator, and the index is always going to be the denominator. Now keep in mind, if we have the nth root, so we're discussing the index, right? So this is our n, so we're discussing the index. So if the index is even, so that means our square root, fourth root, sixth root. So if you have, let's say, for example, the square root of a number that is less than 0, like negative 4. Well, remember, what did we always state? That there was no real solution because this was not just 2, but 2i. So this is no real here. But then if I have if it is actually equal to 0, well, what is the square root of 0? Well, that's just 0, the one solution. That's why it's 1. Then if I have the square root of a value that is greater than 0, so now positive. So the square root of 4, well, that is positive and negative 2 here. So here, that's why we have two solutions for both the positive and the negative. But if the index is odd, so like let's say the cubed root. So let's say I have the cubed root of negative 8. Well, there actually now is going to be a solution. The cubed root of negative 8 is actually negative 2, because negative 2 times negative 2 times negative 2, notice how it's 3 times. Negative 2 times negative 2 is positive 4, yes, but 4 times negative 2 is negative 8. So there is actually now a solution when the index is odd. Then same thing again, if I have the cubed root of 0, well, it's still just 0. And if I have the cubed root of 8, then the cubed root of 8 is actually only going to be one solution, which is 2. So that's the reason why. So basically, if you notice, guys, in the end, the pattern is this. If you have a index that is odd, there's only one solution, no matter whether it's negative, positive, or 0. Versus if you have like the square root, right? If the index is even, you have the one solution here, but if it's negative, that's when we had imaginary, so no real, and then the positive, negative, so two solutions. So here, keep in mind that the fraction that represents the exponential. So again, here, if we need to rewrite it, your exponent was always the numerator and your index is always the denominator. So for example, here we have our exponent, which is in the numerator, and the index, which is in the denominator. So this is like saying that this is 4 being raised to the third power. So this is 4 to the third power. Well, that is inside of an index, so the fourth root of 4 to the third. That is how you're going to rewrite this. So this is the fourth root of 4 to the third power. Now, of course, we could continue, but I just want us to make sure that we're good to go with writing this in our radical form. So now notice we have a power to a power. So power to a power, multiply. So this is 9 to the 6 over 5. So now here we go. Well, that's 9 to the 6th power, so 9 to the 6th, but this is an index of 5. So this is the 5th root of 9 to the 6th. Then here you have -8, which is to the 1st power. Notice how this is like a 1/3 here. So this is the cubed root. So this is the cubed root of -8, because that's just -8 to the 1st power. So notice how the 1/3 is the cubed root here. Now, notice that you have a negative exponent. We do need to flip our base. So this is 1 over b, now being raised to the 1/4. So again, this is now the 4th root. So this is the 4th root of 1 over b, because again, that's all being raised to that 1st power. So that's why this is just the 4th root. This is the 3rd root. So then here now, if I wanted to rewrite this, well, notice how this is a to the 2nd power. So that's, again, a to the 2nd power, but it's inside of what type of radical? The 5th. So this is a to the 2/5. Now notice we've got a little bit more to this one. So first off, I've got f to the 1st power inside of the 6th root. So this is 1 over 6. Then here we've got power to a power. So what do I now need to do? Well, I need to multiply. So this is f to the 5 over 6. Then here we need to simplify because we're dividing and bases are the same. Remember, top to bottom, subtract. So this is 1/6 minus 5 over 6. So this is f to the -4/6. Now keep in mind that this is a negative, so this is the same as, let me bring this down a little bit here. This is the same as, oops, sorry about that. We need to reciprocate, flip the base. So this is 1 over f now being raised to the 4 over 6 power. So that means here we have to the 4th exponent to the 4th power. So this is 1 over f, our base being raised to the 4th power. But again, because this is in the 6th, this is inside the 6th root here. So go ahead and pause the video and try these U-tries on your own. And here we go. So with the first one, notice how this is just c to the 3/8. So that's c to the 3rd power. So c to the 3rd, but inside of the 8th root. Your 8 is your index. Now this one's tricky because notice how the negative is actually on the outside, as if this is like a -1 being multiplied to our base of 6, which is being raised to the 1/4 power, which again is like our 4th root here, because that's just 6 to the 1st power. So this is our 4th root of 6. But because of the negative on the outside, that's why we need negative on the outside. So this one is different, if you notice, than which one here? C. See how C, it's all grouped together in parentheses, which shows that because it's being all grouped together, that this is the value, -8 all together, -8 being raised to that 1/3 power, which is the cubed root of -8. Versus here, I'm going to erase to show you how the negative is on the outside. So really the base is just +6. That's why it's the 4th root of +6. But because of the negative or -1 here, you need -4th root of 6. Then to rewrite this, well, this is g squared, but it's the cubed root of g squared. So again, this is g to the 2nd power, but over 3, because 3 is your index. Then now here, we do have to simplify. So I've got power to a power. So when you multiplied, you should have gotten y to the 5 over 2. Then times, this one's tricky because you have to remember, guys, that this is the square root. So if I have the square root, there's understood to be an invisible 2 here because it's the square root. So this is the same as y to the 7th power, but not over 1, over 2 because that's the square root. Now, because we're multiplying and bases are the same, we're going to add the exponent. Now, this is y to the 12 over 2. Well, 12 divided by 2 is 6. So this is y to the 6th power. Now, these are just some practice on the multiple choice questions. So go ahead and pause the video and try those 2 multiple choice questions, and let's see how you do. And here we go. So reading this says that f is greater than 0, so f is positive. So I'm just talking about how my base here, f is positive. So no need to worry if it's negative or if it's 0. And b is positive. So again, this is not 2 negatives making a positive. This is just saying that b is positive. So what is this expression equal to? So, well, first off, if I have a negative exponent, that means to make it positive, we need to reciprocate the base. So what's the reciprocal of f? 1 over f being raised out to the 4 over b power. So right off the bat, because I have to reciprocate, and this is 1 over f, that means I'm going to mark off A and B. Now I've got 1 over f, which is being raised to the 4th power. So this is 1 over f being raised to the 4th power, because remember the top is your exponent. So this is 1 over f being raised to the 4th power inside of our radical, which is d. So this is our d root here, which means really 1 to the 4th power, and no matter what the root is going to stay as 1. So that's why we still have 1. However, f is still inside of that d radical and being raised f to the 4th power. That's why the answer is D. Then the second question, well, here, which of these expressions? Again, notice how the bases are the same. So what do we need to do? Subtract the exponents, right? So I've got 3 minus negative 1/4. Now, this is 2 negatives making a positive. However, the denominators have to be the same because this is like 3 over 1 plus 1/4. Well, 3, that means I need to make that denominator 4. So if they both have to be a denominator of 4, well, that 1/4 stays. That means if I multiply by 4, we multiply 3 by 4, which is now 12. This means our exponent is 8 to the 13 over 4. Now here, again, notice, remember that this is like saying 8 to the 13th power. So this is 8 to the 13th power, but inside of the 4th root here. So that's why the answer was B. And these are the last 2 questions. So again, pause the video and try these 2 U-tries on your own. And so here, this is like the 3rd root being raised to the 3rd power. So let's just say I wanted to rewrite this. If I wanted to rewrite, that is 8 or 8 to the 1st power, right? So that is 8 being raised to the 1st power inside of our cubed root. So again, notice how there's your 1/3. Still being raised though to the 3rd power. So now what do I need to do? Well, power to a power, multiply. So what is 1/3 times 3? Well, that's just 1. Well, what's 8 to the 1st power? 8. So here, again, you have y, or y to the 1st power inside of the 6th root, which is the same as y to the 1/6. So there's your 6th root, 1/6, still being raised to the 6th power. Now, what do you do with power to a power? Multiply. So now I've got, well, what's 1/6 times 6? 1. Well, what's y to the 1st power? Y. So it's kind of discussing this here. I'm going to erase this. What do you notice now about the answers that we got here? Like we got 8 for this first one, And we got y for the second one, because this is going to be connected to our next lesson, which is solving radical equations. We'll notice that 8 was the radicand. Notice how y was the radicand. That means here, what happened to the cubed root and the exponent? Basically ended up just canceling each other out, right? Because they gave 1. They are inverse operations. So even though I had the cubed root here being raised to the third power, guess what the answer was? Simplified. 8, the radicand. Same thing here. You have the sixth root being raised to the sixth power, which is 1/6. Notice how they just basically cancel each other out, and you are left with the radicand. So they are inverse operations. So like, for example, so that means, right, if I have, let's say, the fifth root of 2 but being raised to the fifth power, well, what happens? The fifth root and the fifth power are inverses, so you're left with a final answer of 2.